Alright, so last video we talked about subsets in their set theory in its written form, and the symbols and what those symbols do. For this video, then, we're going to take a look at how to articulate that with Venn diagrams. We aren't going to look at these, like I said in the last video, these, because they're the exact same as this, they're just looking at it from the other perspective. So if we say that B is a subset of A, then A is a superset of B. I mean, that says the exact same thing. It's like saying Y equals X or X equals Y. So with that being said, then, let's go to here. These are the terms we're going to bring up. We're going to do intersection. We're going to bring up union, which we're going to read as OR. Subset, we didn't talk about this last video. This is the complement, and it just means not. So if we have not A, that would be this. So everything but A. And then we're going to touch on such that. So let's do an easy one to start. We're going to have A union B. So that's A or B. That's going to be all these values. And then we're just ignoring C for now. So just pretend that this circle right here doesn't exist. And then if we were to make this a little bit more complex, we can put parentheses around it and then do another operation. So think about this the same way we do with PEMDAS. We do the parentheses first. So we would start out the same way, right? We have A union B, so that's everything A or B. But then it's asking for where does that intersect C? And that would be here. So we take away the values that C does not touch. We'll get back to those in a minute. I wanted to talk about subsets. So if we define A as the set of Y such that Y is an element of all real numbers. Mess that symbol up. All real numbers, and a new set D is going to be the set of X such that X is an element of A. But we're going to put a constraint on it and say that X is less than 21. Okay, so D by default here is going to be part of A because this is all real numbers. So if we go over here, show our subset, this is going to be D as a part of A. And what's more, because A is all real numbers, even though this is less than 21, this is actually going to be a strict subset because all of D is within A. So there's an example of where you might see this such that notation. We're going to do a basic problem of not, and then we're going to take a look at a couple more complex problems. So if we have A not intersection B. So A not is going to be all of these values, and then we want where it intersects with B, and that would be right here. So that would be A not intersection B. So let's tie everything together now. We're going to leave the such set and subset out, but let's try and make a problem that's a little more complex. Let's do A intersection not B, not, and then we'll do intersection C. So let's try this one out. We'll see if we can get this one done. A, so these values, where they intersect with not B. So not B would be here. So this is where A intersects not B. So this part is done. We're going to go to the outside then, and this is saying not any of this value. So that's going to be all of this area. So this is our current solution. And then we look at where that is intersecting C. So C is being hit through here. There's no C here, no C here, no C here. So this would be our end result. Let's take a look at another challenge one. Let's say we have A union B not, and then the union of C. Or let's do not C. Okay. So first of all, we have A union B, which is going to be all of these. And then we are going to say, no, we're going to take everything but those values. So that's going to be these two. And these are open. And then we do the union of all of these values with C. So these values or C. So that's going to give us, or I'm sorry, that's going to be or not C. So if we have all these values or not C, that would be there. And with that, I think we can conclude this video. Thank you.